Welcome, and we're working on similarity postulates and theorems. These postulates and theorems basically explain how triangles are going to be similar to each other. And the first case we're going to talk about is the angle-angle similarity postulate. Basically what it states is, if two angles of one triangle are congruent to two angles of another, then the triangles must be similar. All right, just to show you an example of the first one here, if we have two triangles, let me go back. If we have two triangles, one's that size and one is that size, and let's just say that this angle and this angle are labeled, if two angles of one triangle are congruent to two angles of another triangle, let's just say that angle matches with that one. Basically what this is showing is that these top two angles are identical to each other and these bottom two angles are equal. Hence, if they're going to be congruent to each other, that means the third one has to be congruent. These triangles are similar. So just showing that they have a similarity. If you continue on to side, 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 what's going on with the side, side, side triangle basically explains if the lengths of the corresponding sides of two triangles are proportional, then the triangles must be similar. What that's showing is that if you have two triangles, let me just make up something here. So I have two triangles here, and the sides of this triangle are 3, 4, and 5. And then if I look at another triangle and it goes 6, 8, and 10, the key word here is proportional. And when they say proportional, they're talking about how does it grow from one triangle to the other. And as you can see, how do you go from 3 to 6 or 4 to 8 and 5 to 10? So obviously, to go from the smaller triangle to the larger triangle, we just times everything by 2. These triangles are similar because they are proportional. And then the last item that we have here is the side angle side similarity theorem. If any angle of one triangle is congruent to an angle of a second triangle, and the lengths of those sides, including these angles, are proportional, then the triangle must be similar. What I'm referring to there, let me draw a picture here. Let's just say that this angle matches up with this angle. And the key thing about this characteristics is that this side, and I'll just call this side 10, we'll call this side 10, it's going to be an isosceles triangle. And then I have to make sure that they're proportional. So if I use 5 on this one and 5 on this one, these triangles are going to be similar. And again, the key thing about this that you have to understand is that side angle side, you almost have to kind of rotate around the triangle in that manner. It's not going to refer to this side, and that angle. You're not going to jump around as an example in this triangle. It's definitely going to go from a side, an angle, and then another side. Like this one, a side, an angle, and then another side. All right, let's look at a few example problems here as we go down. And you can pause the video if you like and watch this. So what you need to see is, are these triangles congruent? And they are congruent. I'm sorry, let me not say congruent here. Similar. Are these triangles similar? And yes, they are similar because they are proportionally. If you look at how these grow from one side to another side, this one goes to that one, this one goes to that one, and this one goes to the other side. Really, if you take each one of these numbers and times it by 6, times it by 6, times it by 6, is proportional. They're going to be similar triangles. The catch here, though, is that you got to make sure that you do it in the right order whenever you write the triangle. Since this goes CBA, I got to make sure that I start with this angle. What's the corresponding angle over here? F. And then I got to make sure that I'm, again, being proportional with this. Make sure I continue the same pattern. B is the second angle, G is the second angle on this one, and the last one on this is A is the last angle that I'm identifying, H is the last angle I'm identifying. So the final answer on this would be, and you have to identify it with a triangle since you're talking about a triangle here, is FGH. And you must put it in this order so that you can show that they're going to be similar. Look at the second example. Again, you can pause the video if you like. If you look at this, these triangles are similar again. And again, you just have to kind of go back and look at the rules. Is it angle, angle? Is it side, side, side? Or is it side, angle, side? As you can see from this description here, these triangles, those angles, I should say, I'm sorry, those angles are identical to each other. These angles are identical to each other, meaning that the remaining angle that's not labeled here is going to be identical. And again, I have to label this in the same order that they have the question stated. So triangle JKL is going to be identified. Now, I kind of did like a teal color and then like a purple color and then a square, a pink square. I got to do it in the exact same order. So in this case, it's going to be TUV. Let's look at a third example. Now, in this one, it almost seems like there's not enough information given. But whenever we have two lines that are intersecting, what that means is that these two angles here, vertical angles, they're called, the vertical angles are going to be congruent to each other, identical. So obviously, when we look at this angle matches this one. If I look at another one here, this angle matches this one. And just like the last problem, since they already have an angle that is similar to each other, the triangles you can say are similar to each other. So as you go around this, and again, I'm going to try to label it with different colors here. Since they use HGF, they use H first, they use G second, and then they use F third. I got to make sure I go around and use it in that same order. So H is first, G is second, so which one's G? Since G is labeled with a 61 degrees, T is going to be second. And the last one here, F is the last one, the unlabeled angle, so S would be the last one. So the way that I would state this is H, I'm sorry, let me start with the ones that are not given to you. So the way I would state this is HTS. Last problem here, similarity postulates again. You can pause the video if you like, try to identify. And it has to either meet the angle, side, 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 or side, angle, side postulates. And as you can look at this, and again, you have to kind of identify some characteristics about it. Since this angle matches this angle, and as you can see here, the 9 matches up with the 27. The way I go from 9 to 27 is I just do times 3 by that. And then if I look at another side, 10, how do I go from 10 to 30? I times that by 3 as well. And as I go through this, basically I'm showing that the triangles have a similarity. The similarity, as you can see here, is TUV. So I want to go from that order again. I want to use T and then U and then V. I have to make sure I'm same on this triangle up here. So in this case, it's going to go from C. Since it goes to the 30, it goes in this order to D. And then since it goes up to the last one here, to E. So the way I write my very last one is going to be C, D, E. And hence these triangles are similar to each other. Thank you.